Hello students of grade 9. We're going to do exercise 8.2, question number 4 and 5 in the same video. Question number 4, they've given a trapezium where they've given AB is parallel to DC and E is a point, midpoint of AD, and EF is parallel to AB. EF is parallel to AB. And you're going to prove F is a midpoint. They have not given a point here, you can write 1 point here O. First you write AB parallel to DC and EF is parallel to AB is given. Implies every line is parallel. These two lines are parallel, these two lines are parallel. That means all the three lines are parallel. You can implies AB parallel to EF parallel to DC. All the lines are parallel. Now for these two questions, we have to use converse of midpoint theorem. So first take this triangle in triangle ABD. In triangle ABD, E is a midpoint. Midpoint of AD, it's given. And this line is also parallel. EO is parallel to AB. Clear? Now, if in any triangle there is a midpoint, one midpoint, and the line is parallel to this base, that means O also become a midpoint. Therefore, O is the of BD. Reason is converse of midpoint theorem. See, I have already explained converse of midpoint theorem. If P is a midpoint and the line is parallel, that means Q also become a midpoint. That is converse of midpoint theorem. If one midpoint is there and the line passes through that point is parallel, then the other point also become a midpoint. Similarly here, E is a midpoint and it passes, and this line is parallel, the other point here, this also become a midpoint in the triangle. Now let us take this triangle. In triangle BCD, we can write O is the midpoint of BD because we have proved already. You can write proof above. Now see, in this triangle, O is the midpoint and OF is parallel to DC. Since the line is parallel, even OF will be parallel to DC. So we can write OF is parallel to DC. Therefore, if this is a midpoint and this line is parallel to this base, that means the other point also become a midpoint. So we can write F is the midpoint of BC. Reason is converse of midpoint theorem. See, the proof is done. We have to prove this is a midpoint of this line, so we got the proof. Hence proof. You can pause the video to write the solution. Let's go to next question. In a parallelogram, E and F are the midpoint of this line. These two lines. Show that the line segment AF and BD trisect this line. Trisect means they are cutting, these two lines are cutting this diagonal in three equal parts. That means we're going to prove BQ equal to PQ equal to DP. Clear? Trisect, three equal parts. Now what you have to do is, first take this one, AB equal to DC. You can write AB is parallel to DC and AB is equal to DC because they are opposite side of reason is opposite side of parallelogram. Clear? Now if I see AB parallel to DC means even this line will be parallel to this line. So we can write AE, because AE is part of AB, parallel to DC is also part of, CF is also part of DC, so FC. And here you multiply by half. Half AB equal to half DC. So AE parallel to FC. If you multiply by half, half of AB can be AE because E is the midpoint, and half of DC can be CF or FC. That means we're getting these two lines are equal and these two lines are parallel. That means this figure is a parallelogram. We can say AECF is a parallelogram. Reason is opposite sides are equal and parallel. We have proved that opposite sides are equal and parallel. That's why this figure become a parallelogram. If this figure is a parallelogram, that means this line is parallel. We can say therefore AF is parallel to EC. Clear? Now we'll take one triangle. Let us take this triangle. Concentrate on this triangle. In triangle DQC. In triangle DQC. F is the midpoint. We can write F is the midpoint of DC. And these two lines is parallel because the whole line is parallel, means part of the line will be parallel. We can write PF parallel to QC. Reason is AF is parallel to EC. The whole line is parallel, so part of the line also will be parallel. That means we are showing that in this triangle we have one midpoint and the line is parallel, then the other point also become a midpoint. We can say therefore P is the midpoint of DQ. Clear? Reason is converse of midpoint theorem. Now P is the midpoint of DQ, means DP will be equal to PQ. Clear? Now similarly, if I take this triangle, I will be able to prove these two are same. Similarly, in triangle ABP, PQ will be equal to BQ. We'll be able to prove that this is a midpoint. That means PQ and BQ will be same. Clear? So mark this 1 and mark this 2. From 1 and 2, all the sides are same. DP equal to PQ and PQ is equal to BQ. Therefore it trisect. Okay? Pause the video to write the proof. Thank you. And